All of them but C.
I'm gonna just shout out to me.
Oh,
Shout out to them.
Shout out to Adam Burkett.
All right, Elizabeth, you got anything for me?
I just completely spaced out.
Okay, you back yet?
I'm a little bit.
Okay, but not yet.
Not yet.
Not yet. All right, got anything? Kylie, got anything?
A, B, and E.
A, B, and E would be correct. A, B, and E on that one. So remember, here's your A. Would be your plus or minus 1, plus or minus 2. Here, B would be 1, 2, 3, and 6. And then when you divide B over A, you always get all the constants because you're dividing by 1. So it'd be 1, 2, 3, and 6. And then divide by 2. And what unique factors we get? We get 1/2 and we get 3/2. And so, and one thing you got to watch, I think, on this is like sometimes you just quickly glance through it. You don't think through it. It's easy to pick the wrong one. Okay, so just take your time there. All right, we need to, like I said, finish up section 3-4 here. All right, write this one down. List the possible zeros. They're actually going to be the same as the one we just did. So go ahead and list those, but don't start trying anything yet. I want you, because I wanted to do something to, so something happens. And we end up with 1/2 and 3/2. Okay. All right, those are all possible zeros. We actually have what, 2, 4, 6, 8, 10, 12 numbers to choose from for a cubic. All right, now before we do anything, I'm just going to go off on a small tangent here. Using the factor theorem. Okay, remember we talked about that. If x is a root, or let me say if 3 is a root, what's a factor? Okay, just remember, you plug in 3, you get back 0. Remember, what is a factor? Make sure I'm making any sense here for that one. Caden, do you remember?
no.
Avery?
X minus 3.
X minus 3. All right, yes. All right, so, and just pay attention to this. You don't need to write this down. If 3 is a root, X minus 3 is a factor. If -2 is a root, what's a factor? X plus 2. Okay. All right, what about 2/3? If that's a root, what's a factor? 3x minus 2, right? And then what if you have negative, I don't know, 1/3? What's a factor? It would be 3x plus 1. All right, so this is going to come up here. All right, so if this is 2x cubed plus x squared minus 13x plus 6, and in the end, when you factor it, think about this. Could this be, could we have 3 factors that look like that? No, because x times x times x gives me what? X cubed, and I need a 2. So one of these has to have a 2. So if you have a 2 in front of here, what's that going to tell you about one of your solutions? It's probably going to be a fraction. Okay, so that's kind of where we're leading. So I want to kind of force the issue because you need to see how to do this. Use synthetic division for x equals 1/2. Okay, and then just wait. Use synthetic division. It should be a root. And just put 1/2 in the box. And 2, 1, negative 13, 6. All right, so add 2 plus 0 is 2. 2 times 1/2 is 1. Add those together, you get 2. 2 times 1/2 is 1. Negative 12 times 1/2, negative 6, 0. All right, now here's where you got to be careful. Now hold on 1 second. What we just talked about, we said 1/2 is a root, right? Or 1/2 is a root. What's going to be a factor then? 2x minus 1. But here's how you got to start. You cannot write out 2x minus 1 yet. You got to start, like if this was 3, we'd write x minus 3. If this was 4, we'd write x minus 4. So we got to do this. F of x equals x minus 1/2. This is how you got to start that. X minus 1/2 times, whoops, 2x squared plus 2x minus 12. Remember, we get that from here. All right, what do you notice about that trinomial? It has a GCF of what? Factor that out. Take the GCF of 2 out. And I'm going to put it all the way in front of this x minus 1/2. And I get x squared plus x minus 6. Now distribute your 2 into there, and this is where you get your 2x minus 1. You can't immediately start, even though 1/2 is a root, you can't immediately start and say 2x minus 1 is a factor. You kind of got to go through these steps here. Factor out the GCF. And so now I get 2x minus 1. Now that'll factor there. What's x squared plus x minus 6 factor into? X plus 3, x minus 2. And so there we go. I think, I forget what the direction said. List of possible. So we're going to find all the zeros. So my zeros are 1/2, negative 3, and 2. So we'll end up with that factor of 2x minus 1, but like I said, you just can't immediately write it down. You got to start with x minus 1/2. Or no matter what fraction it is you use, you get a 0. You got to start with x minus that fraction to make everything work. All right, we talked about that. All right, same thing, but we're going to kick it up a notch. We're going to go 5th degree. So find all the real zeros, rational and irrational. Technically, I shouldn't need to list that. When it says all the real zeros, that could be anything. And write f of x in factored form. All right, so think about what your zeros are. And once you get to there, just pick one and try one. And if it works, just wait. And if it doesn't work, just wait as well. Don't worry about going, and we'll figure it out from there. Somebody will find one. So list all your zeros and test at least one. All right, so my A's are plus or minus 1 and plus or minus 2. And my B's are 1, 2, and 4, all plus or minus. And B over A is plus or minus 1, plus or minus 2, plus or minus 4, and then I get I just get 1/2, right? That's the only extra one I get. Because 2 divided by 2 is 1, and 4 divided by 2 is 2, and I already have those. All right, pick one. Pick one. Test it. Now, what's missing here? Oh, we gotta be careful. It's missing a what term? It's missing an x squared, so what do we gotta put into that spot? You gotta put a 0. So whatever you put in the box, yeah, make that 2, -1, -9, 0, 10,
I got 2.
4. Okay. Now, since it starts with 2 x to the 5th, what should a possible root be? Should be a fraction. Okay, on that one. All right, so test, see what you come up with.
Be careful.
We get the -1/5.
Shout out to Thomas Cassidy.
It's the X squared.
Thomas, we miss you here. We miss everybody who's not with us. Mason, we got Adam. Won't be long till you're back with us. All right, what works? -1 works. Agreed? What else works? -1/2 works. 2. Okay, now wherever you're at, that's fine. I'm gonna start with -1/2. If you found a root, then just kind of pick up from where you are at. And if you didn't find a root, I'm gonna plug in -1/2. Okay, and so when I go through that, and so I get 1, then I get a -8 here, +4, -2, 8, -4, 0. So what we have is, I want to make sure you see this, is that we get x. If it's a -1/2, we make it a +1/2, x + 1/2. And so now I got 2x to the 4th power minus 2x to the 3rd power minus 8x squared plus 4x plus 8. So if you get a fraction, you should have a GCF in that remaining polynomial. And so what can I factor out at this point? I can factor out a 2 of that whole thing. And more than likely, you're just going to make it 2x plus 1. I'm going to factor it out here, and I'll eventually make it 2x plus 1. But now that gives me x to the 4th minus x cubed minus 4x squared plus 2x minus 4 for that. Now, each time you reduce it, you change like your possible zeros. So you're probably going to shrink them because this has a term of 1 in the front, and this is a term of 4. So basically, it's going to come down to ±1, ±2, or ±4. You shouldn't have to try the 1/2 at this point. All right, what did we say? Somebody said -1, right? Somebody said 2. All right, so at this point, you're going to have to plug them both in. I'm going to start with 2 into 1, -1, -4. 2 and -4. What I do wrong? +4? Thank you. All right, there we go. Here's where I'll tell you what happens. Here's the biggest mistake people make on these, and you'll end up sometimes not solving it. If you pick a number that's a root and you make a mistake in your math work here, and you end up getting a remainder where you should get a 0, then you're in trouble because you're gonna like say that one won't ever work. And so you just kind of forget to ever try it again. So if you can't get something to work, you might have to go back and revisit, make sure you copied these numbers down right. Like that's what reminded me of it. And make sure you did your math work right. Because if you don't get a 0 where there is one, because of just an algebra mistake, then you're going to be stuck. Okay, so now that's 0. I'm going to distribute the 2 into here now. So I got f of x equals 2x plus 1. And then this, since this 2 is a root, I get x minus 2. And then I got x cubed plus x squared minus 2x minus 2. And then what do we say for that last one? -1? Now what's our goal? Our goal is to get it down to a quadratic. Because once you get it down to a quadratic, you can always do quadratic root formula, or hopefully it factors. And then, so if I put -1 here, -1, 1, 1, -2, -2, 0, -1, 0. I did something wrong. 1, 1, -2, -2. That's a 0. And that's -2, and that's 2, and that's 0. So now I got f of x equals 2x plus 1 times x minus 2 times x plus 1 times x squared minus 2. All right, so we got 5th degree. We want to keep going. We got it all the way down to a quadratic. But we want to list the zeros. We got -1/2, +2, -1. What do I do with that x squared minus 2? So we got to see where that equals 0. So just think about this. X squared minus 2 equals 0. And then probably the easiest thing to do is add 2. And then take the what? Square root. And we get x equals plus or minus square root of 2. All right, now this, since this is an irrational, a lot of times they'll tell you to factor it down to linear terms, and what's called an irreducible quadratic is irreducible because it doesn't factor. So you could leave it like that, and we'll eventually show you how you can write the, if it's not a nice number, is the factored form as well. But in the end here, my zeros, what are my zeros? You said -1/2, +2, -1, and then positive square root of 2 and negative square root of 2. How many times does that graph hit the x-axis? It hits it 5 times. Okay, the square root of 2 is a value, it'll hit right there, and then negative square root of 2. Okay, we're going to save that for tomorrow. I'm going to take off 93. These take a little bit of time, so I wanted to give you a little bit of time, especially if you're a bad guesser. You're a good guesser. Doesn't take quite as long. So get as much done. If you want to, just toy around for fun, you can try 93. Either that or you can watch the number file videos. Those are always fun to take a look at.
This is all on recording, I'm just saying, so it's making me look like a bigger nerd over there. Who? You, it's all on recording, but you would like tell your students to do more math.
Well, yeah, what's wrong with that? Why, who would want to do more math? Come on, Clem. We're going to go out and run?
Yeah, running. People watch those running competitions and like marathons. Marathons, I don't know.
He's gonna start comparing the data now or now. I don't wanna do something.